What is Mender? Mender is over-the-air software updates for embedded Linux devices. Mender is an open source tool for updating your embedded devices safely and reliably. Mender's latest release as of today, June 19, 2017, is 1.1.0. How does Mender work? Mender includes two parts. Part 1 is an updater client, which runs on devices. Part 2 is a management server, which runs on a host. Update client from devices poll for updates, download and install updates if it is available. This diagram shows the whole process of the Mender updating system. First, device software build system will build everything from U-boot to kernel to rootfs. The final product is an artifact file, which Mender calls a .mender file, that contains everything. The management server will upload the Mender file and manages the Mender file. The .mender file represents a specific update in the process and for the devices. The Mender Server. The Mender Server interface has 4 tabs: Dashboard, Devices, Artifacts, and Deployments. The Dashboard tab shows deployments in progress at this moment if it is available. Also shows recent deployments, results, and their status. The Devices tab. The Devices tab, which I believe is the most interesting tab. It shows all connected devices. We have the unique device ID, we have the device type, Paidia a20, we have the current software in my testing environment, version 1.0.2, and last heartbeat, 15 hours and 51 minutes. My system time at this moment is 15 hours and 52 minutes, which means the target reports its status back 1 minute ago. We can also click on the device. It will show more detailed device inventory data. Other than ID, MAC address, and first connection time, we also have extra data like artifact name, which is exact as the current software, device type, host name, IP address, kernel version, MAC address again, memory, and Mender client version, network interfaces. The Artifacts tab. The Artifacts tab shows all available update files on the server. Each update file has a unique descriptive name. We can see that with a few here. I've been using version 102 and 103 as good updates to testing Mender mechanism. I've also made intentionally bad update files such as missing U image and no network for testing purpose later. Device type compatibility, Paidia a20 board. If we do have another board, for example C2, then one of the update files is only intended for C2 board, then C2 will be shown here. Last modified timestamp is the time when the update file was first uploaded onto the server. The Deployments tab. The Deployments tab shows all past deployments data. First, it has updating to, which means which update file that certain update used. Group. At this moment, we have all devices. We actually can create very specific groups to make the update more manageable. For example, we can create Paidia a20 group, we can create C2 group, and we can even create handheld group to solve the devices and easily manage different category devices. Started and finished the time of that update, number of devices of that update, and the status, successful or failure. We can create a deployment from here. Select which update file we want to use. Select a group. If we created Pedia handheld, we can select that. And we can see that it automatically detects that as one device is available to do this update. We can click Create Deployment button here to create one. Once a deployment has been created, it will be pending, and Mender client will poll the server and start the update process. Now, let's do a testing on good updates. We can see that from Devices tab here, this testing unit is running Pedia a20 version 1.0.2. We can see the inventory data of this unit. We will create an update to update this testing unit running version 1.0.3. After the update, we'll see from here again that the current software will be Pedia a20 version 1.0.3. Okay, let's do it. We go to Deployments tab, create a deployment. We select 1.3 and all devices as a group, and we have one device available. And then we create deployment. We can see that once the deployment has been created, it starts as pending status. Once the Mender client on the target starting to install, you'll be showing on installing. Now the update status has changed to installing from pending, which means the Mender target has detected the update and start to install the update. Let's take a look at the details of this update. From the dashboard, we can see that deployments in progress. And we can click on View Report. We can see detailed information about this update. We can see that it's updating to 1.3 group and device number. How long has this device update in progress? The device ID, type, and current software. When it started, and status is installing. Waiting for the update to complete, we can actually observe the logs of the Mender service target. We can see that Mender trying to periodically check update and trying to periodically update inventory data. And once it detects an update available, it started to fetch and install. In this case, we can see that it's opening partition number 2 to upload and update the new image. And it writes to partition MMC BLK0P2 and size on the target. Let's take a look at the deployment progress reporting page. The deployment status is now success, which means the update is successful. Basically, what is underneath the Mender mechanism is that the Mender client will report back what is running at this moment after the update to the server. Then the data will be checked against what is supposed to be there. If they're matching, which means a successful update. Now, let's take a look at the device status through Devices tab. We can see that the current software now is running version 1.0.3. It was version 1.0.2. A little more inventory data. Everything is the same except artifact name, which is the same as the current software, which confirms and verifies that the last update was successful. Next, we'll do a bad update testing. For example, if anything bad happened that a device failed to boot, no matter what, power failure, corruptions, or anything is not working and the U-boot just cannot proceed. For this purpose, I create a missing U-image update, which means there's not even a kernel image there. The U-boot would not even able to load anything. So this will represent a certain category that the device has failed to boot. It never started to load kernel and start booting. So let's do it. First, go to deployment. Create a deployment. Selecting missing U-image update, all devices. And our testing device is available to do the update. And create deployment. First, the status will be pending. As soon as the target client Mender service detect the update, it will start to update, download and update the image. Now the device is rebooting. We can see that U-boot could not find U-image trying to boot from network, and that's all the message is about. This is an example of failed update. An update just failed the unit and failed to boot from U-boot. So in this case, a reset, either triggered by manual reset or a watchdog in the system that will reset the device, will fix the problem, will bring the device back to the previous known working state. We can see that the U-boot dropped out to command line interface and just waiting there because he could not boot. So in this case, let's just reset the device manually. I will disconnect the power and connect again. System rebooted. We can see that now we go back to previous known working state and system is booting. And IP address assigned for 110. Let's take a look. After 21 minutes, 50 seconds updating process, the system boot back with previous known working state, and the Mender client reported back data, and the server decided that the update failed. It's a failure. So we can see that from here. Let's examine the current device status. So we can see that the current software for the testing unit is version 1.0.3, which was version 1.0.3 before. And the artifact file we tried to update is 1.0.4 and failed. So the device dropped back to the previous known working version, which is 1.0.3, which confirms that Mender is doing a good job to keep the device. Now let's do another important testing where system is booting, but the network is not available. Either the device driver is not working or the credentials is not all right. Anyway, the IP address is not there, is not connected to the network. We're going to see what's happening, see if Mender can guard against this scenario. Let's do it. Go to deployment, create one. We're gonna do node network, devices, and we create. You can see that the device is now rebooting after update. Now the device is rebooting again because of the network is not available. Deployment progress reporting page report another failure of the previous update. Let's see the device status through the device tab. We can see that the device is still running the current software version 1.0.3, which is the right running working version. The last heartbeat from the device is 17 hours 59 minutes. My system time currently is 18 hours, which is 1 minute back. The unit reported its status to the server. This verifies and confirms that Mender can guard against critical system failure like the network not available scenario. We have gone through what is Mender, how does Mender work, one good update testing case, and two bad update testing cases. One is the missing kernel image, U-image. The other is missing network connections. Thank you for watching.